I'm Vice President of CERC. And then this is Dr. Ryan. I'll let you introduce yourself a little bit if you'd like to.
So I'm Dr. Ryan. I'm an associate professor in applied math and statistics, and I work on numerical solutions to partial differential equations.
Perfect, thank you. And then can you tell me just a little bit about yourself and like how you got to kind of where you are here, you know, working at Mines, the research you're doing, kind of all of that. Just a little more detail.
Yeah, well, I'm originally from Texas, actually. So, but I spent 12 years in Europe. My background, I never thought I'd be a mathematician, but you know, I just was guided towards that way through university. After taking differential equations, and I became obsessed with the many ways different equations can be used for different applications. And then I had an undergrad advisor push me towards graduate school and getting my Ph.D. And that was it.
Yeah. And then, you know, I feel like this is a little bit kind of more of a stretch than people would normally think about. But how do you think that, you know, work in math and especially higher ed, how does that pertain to the public, you know, with the research you're doing, that kind of thing? You know, is it more self-contained, or how is it connected to kind of broader society?
Well, so mathematics doesn't always have a direct application immediately to society. So for example, modular arithmetic is used in modern cryptography. But in the applied math department, we're hoping our research does have impact in different areas. So we have a lot of good research going on in our department. For example, in mathematical biology and climate modeling. And my particular research is in designing better techniques for simulating things on a computer that perhaps could be used in medical imaging or designing better vehicles.
Yeah, that's interesting. I feel like people don't often think of the direct applications and things like that you know it could be used for. It's really interesting. And then about your research specifically, like how did you kind of get involved in that particular area? And like what's your end objective with it?
Well, so as an undergrad, I took numerical analysis, and it was easy for me, and I liked it. And in graduate school, I just had an advisor, and I took a course on numerical PDEs, and it was like learning by osmosis, I would say. And yeah, so I chose an advisor in that area. He got me started. So yeah. And he got me started on a project that has grown into what I do today, which is extracting more accuracy out of data. So I work on mathematical techniques that allows us to see more information than we think is there.
Interesting. Have you done, or do you have any specific examples of like data that you've worked on or anything like that?
Well, so one of the data types I want to work on is in turbulence modeling. So turbulence occurs in many areas, and it's very difficult. That's such a complex system to model. You really need different techniques in order to look at the turbulence. So and you have stuff that really needs to be modeled at a very detailed data level. And you have stuff that needs to be modeled at a course level, and you need to match this information. And so I work more on the mathematics of that rather than, so how to do that.
And then kind of our initial connection was over the Applied Math and Statistics Department Colloquium series this fall on math and social justice. And so can you tell us a little bit more about kind of that whole how that kind of topic came about, and then maybe some examples of what has been talked about as well, kind of throughout that series, what that looked like, and yeah.
Well, so it came about because one, I was the diversity, inclusion, and access chair for our department, and two, I was colloquium organizer. And when COVID happened, of course, we as a society had more time to observe what was going on in the world. And then George Floyd was killed, which caused us to be more introspective in our role that contributes to how society functions. And we have excellent students in the applied math department, and they wanted a venue to discuss this topic. And so last year we had a book club, and we explored 2 books, Weapons of Math Destruction and Factfulness. But this year we decided to change it up a bit, and there's a lot of mathematical institutes that are funded by the NSF holding workshops discussing these issues. So we decided to take advantage of that. And the idea is that we learn a bit about the subject and then we discuss it. So that's how it came about. And some of the topics, so we opened with a mind belong. And she was discussing modeling of the hierarchy of leaky pipeline. So as you become more senior in your career, there's less diversity in leadership positions. So, and of course, modeling that helps you see what contributes to that. And then something that would build, that kind of builds upon the Weapons of Math Destruction book is data science and social justice. So that was the second in the series. And then recently we had we were looking at fairness in the sentencing of in the federal judicial system. So these are some of the topics that we've looked at.
It's really interesting. What do you think, like, the key takeaways from that kind of were, the different sessions individually or kind of as a whole?
Well, I think it's one of the things as a whole is that this is really an area of research that needs a lot more work. So it's just the beginning. We're starting to look at the data and how we look at the data, how we create the models. There are lots of parameters going into these models, and so it's not easy to look at. And also, well, something that occurs from our discussion of our book last year is once we understand how things are modeled, we need to be careful at how the models can be misused.
That's really interesting. Really interesting.
Well, I should also, just to go back a bit, our excellent graduate students that wanted to discuss these topics in a venue, wanted to have a venue to discuss these topics. They started student organizations called Minds, Mathematics and Computing Collaborative. So they recognize that that not all of us have the same access in education. So they are there to hold workshops for Denver public school students as well as Aurora and anywhere surrounding. So they've designed a series of workshops to stimulate student interest in mathematics for those that might not have access.
That's really cool. I like that as a way to kind of, take these topics in, an academic setting and talk about them, but then, take the values and things that are being talked about and putting them into practice almost.
Yeah, we have excellent students that, they really care about the world, and it's wonderful to see that.
Yeah. So kind of more generally, we've been talking a lot about math specifically, but in the larger like engineering and science realm, how do you think the work that's done in these fields is kind of needs to be accountable to the public, or the scientists and engineers? How do they need to be accountable to the public?
Well, I think we need to do good science that is fact-based, uses solid techniques to address important questions, and our research needs to be replicable and compared to existing techniques. And we need to be open about our models and how we constructed those models and where the data came from and what the data answers and what it doesn't. Of course, the problem is that we also can't interpret those results for the public, but we also need to do this in an unbiased way.
Mhm.
So,
Yeah, and this is a little tricky because human issues are not black and white. There's a lot of gray area and conflicting interests and needs and that kind of thing. So, how might concerns be prioritized? If there's like a benefit to one community that might cause harm to another, that kind of thing, or how might cultural constraints or social justice issues play into the accountability questions?
that's a very difficult question.
Yeah, for sure.
I don't think there's one right answer. I think part of our job as scientists, in order to inform and to make sure our work is unbiased, is we do need to explore all the issues.
Mhm.
But prioritizing one area over another, I don't think there's a one answer for how to do that. I think it's very dependent on the background information.
Mhm.
And that requires us understanding the different perspectives, but also the history, because there's a lot of history as to why a particular situation exists.
Mhm.
And one of the things that I like about the US education system is it's a liberal arts education. So we're taking the humanities courses. And this is so important for creativity and for examining different issues and perspectives. So this is one of the great things about our system.
You mean on a like primary education level?
Well, even at the university level.
Mhm.
So in Europe, you just go immediately into whatever you're studying, which has its advantages. But I really think there's a lot of value to taking further history courses than what's taught in our school system. Taking a language course, taking a course on films. There's it causes you to see the world differently. I think that's quite important.
Mhm. Yeah, and you mentioned you lived in Europe for a long time.
Yeah.
How else have you seen that kind of impact, the engineering and science, that kind of thing that comes out of different places? I didn't word that very eloquently, but how does that impact, the work that's done or the perspectives of professional scientists, do you think?
I think we're very, very much influenced by our individual perspectives from the way we were raised,
Mhm.
right? This is ingrained into us, whether we recognize it or not. Is this perspective?
Uh-huh.
And so we need to recognize our limitations and open ourselves up to new experiences.
So, yeah, do you think their approach to science is different? Like are people trained in European universities, less focused on the human centered since they don't have that depth of liberal arts in
Not
addition
necessarily. So in the UK, there's this thing called the Athena's One Award,
to?
and this is a commitment to diversity, and all universities now are required
Mhm.
to have that. And so every 5 years you have to reapply, and in order to obtain this, you have to show that you've actually done something.
Mhm.
And that you're making progress to equalizing things.
really interesting too. So to kind of, go back a little bit towards your research or, research you've been involved in, how much is the kind of human side or human impacts of the work considered when developing proposals or research questions, kind of the initial stages?
So being a mathematician, my research is more fundamental, which is great. It's a lot of fun, right? I have the pleasure of not always having to worry about the long-term impact. But what that means is the human impact is more in the people I work with, choose to work with, and develop collaborations, and in students and postdocs I choose to hire. So it's really about building communities and building communities that consider these issues in their work.
So more on the kind of research team and
Yes.
people behind it. That's interesting too.
Yeah.
Even though it is, like you said, kind of fundamental, but there's still this aspect to it, even if it's a little bit.
Yes, and when your proposals are evaluated, then they take that into consideration.
I was just curious, when you're talking about building the community and like being very thoughtful about like who you're hiring and such, what are the kind of things that you're looking for?
I don't necessarily go for the student with the straight A's. I go for the student that's inquisitive and willing to admit when they don't know something, but are curious enough to find a solution. And someone that's willing to learn from others and work with others, and integrity is very important. So that's some of the things I look for in a student.
And since you said you were the diversity, inclusion, and access
Chair,
Chair,
previous.
okay.
Yeah.
I assume that means diversity is also important to you.
Yes.
How do you ensure that like your team has diversity in like all the different forms that diversity?
That's very difficult because, for example, here I don't necessarily have the ability to hire someone directly to a project. That's another different thing about Europe, is that I don't hire the Ph.D. directly. They're admitted into our program. But our graduate chair, Karen Liederman, has done an excellent job in assuring that these aspects are considered when we're looking at applicants. Not everybody has the same access to opportunity. So yeah, we have to recognize that, and we have to do something to overcome it.
Yes, I meant to mention this previously, but if you have any questions that you'd like to ask or any, follow-ups or anything like that, please feel free to raise your hand and we're happy to include those for sure. But with that, has anyone been holding anything? Thank you, Cassidy. Yeah.
So I know you previously talked about accountability in your research of data and not interpreting that for the public, just remove as much bias as possible. I was just wondering if you have those models and the data sources as well, and there are some public communities that aren't able to easily interpret those things. I was just wondering how your approach would be to that, in understanding that sometimes huge models and data sets aren't always easily understood by the general public, and how can we kind of bridge that?
Yeah, well, this is interesting. So my former institute was the one where in 2008 there was a data hack, and an email contained "we do this trick," right? Which they just meant we apply a technique, a scientific technique, to the data. But of course that was misinterpreted. So we do need to be careful about access to, well, not access to the data, but how it is interpreted. But that also goes, that's more for us. We write scientific articles that might look at data or look at generating data in that scientific article, it's very important that we include all aspects of our research. And that's publicly available. It's difficult for people to read, but then, for example, American Mathematical Society has come up with these mathematical reviews where you're supposed to summarize what's in the article. And I think that this is something that will become more common in the future.
Thank you.
Related, I think there's a term that you hear a lot called confirmation bias. And I think it's often applied in things like race relations and other types of kind of socio relational experiences. But I think the same problem exists in interpretation of data.
Yeah.
Is that something that the mathematics community has thought about, especially the modelers and the data analysts and interpreters? How do you deliberately try to wipe out the confirmation bias in your analysis of data?
Right. It's difficult, I would say. This is where replication, not necessarily by you, and providing the underlying data is important when, for example, the article is reviewed. Because perhaps that person has a different perspective and they might see the data in another way. But also your models and techniques, they shouldn't be doing this confirmation bias.
Emily and I are in a class together where we look at different ways of communicating our designs, our data work that we do, and we did a project recently on data visualization. And I'm curious to know how, I guess, your team thinks about that, and how you're visually going to present data, and how you think that would impact that kind of biases, or even just other perspectives that come with being able to understand the data.
So there's a really interesting thing that occurs in my field, that people design these techniques and then they don't plot all the information. So you might not see oscillations in data that you're trying to get rid of. And many people don't report that they're not plotting all of that information. So this is what I mean by including all the information in when you're reporting your results. Is you need to, the most mundane things you need to discuss when you're reporting the results. So, this is how to overcome that is to report even the most mundane things. And so all these articles are reviewed by other scientists. And as a reviewer, it's your job to look at the material, the new model, the new work that's presented, and look at it from all aspects and really question that material. You shouldn't do that in a very negative manner. Your job as a reviewer is to just question the science and help the researchers improve either their presentation or their model. Your job is not to criticize them.
So something a little bit more meta. Do you think that, scientific research, maybe math specifically kind of benefits humanity just inherently? Or is that something that kind of, comes in the applications, like you said, applying it to different kind of uses, or is kind of just the knowledge gained beneficial without that?
Well, personally, I can say mathematics underlies most of science and engineering, right? So therefore, It does benefit humanity, but yeah, I mean, we have the pleasure as mathematicians to not worry about that as much. But yeah, I definitely think that it does eventually impact humanity, whether we like it or not, right? So facial recognition software is great for unlocking your phone, but not so great if you participate in a protest and people try to identify you in that protest, right? So
Yeah, that's an interesting example. Do you have, any others you think of off the top of your head that kind of can go either way in that manner, be a positive benefit or a negative?
well, social media organizations, right? They have all this access to data and they can steer the conversation in a direction that they want it to go. So, and they have the choice, right?
That's another interesting one. Definitely
Yeah.
massive topic too that you could
Yeah.
go right into. You also briefly talked about like good science and kind of what that entails.
Yeah.
In terms of methods and that kind of thing. Will you elaborate on that a little bit more?
So yeah, I would say first, it's important to recognize good science is not a zero-sum game. It usually relies on cross-discipline collaborations. And this is very important. And as I emphasized a few times, replicating results is important. Making sure you're using solid techniques. Making sure you're comparing techniques to other existing techniques. So for example, machine learning is very popular now. But in our rush to publish and get our research numbers better, we often overlook comparisons to existing techniques, honest comparisons. So for example, we don't include how long it takes to train a neural net. This is something.
And good science obviously is really essential, and like you said, multidisciplinary a lot of the times too, which I think is something we talk a lot about in the HE program. But how, kind of in the education component, can we train, future scientists to be really mindful of this and really focused on making that a priority?
So we're becoming more and more dependent on cross-discipline collaboration. And I think we need to incorporate that more into the way we give courses, but also we need to challenge the way we give assessments, right? We need to include more collaboration on those assessments, but we also need to ensure that you as students are not afraid of saying, I don't know the answer. But of course, you should learn the answer, and you will often learn more from your peers than from the lecturer. So I think that's very important. I think there's several things we can do in terms of that.
Have you tried to integrate that into anything you work with students with? Or?
Yeah, so you have to do the community building in the classroom as well. And maybe not this semester. I've only had one homework where it was collaborative. But usually I have homeworks that are very collaborative. And of course, when you do that, you have to have a mechanism to say, this person did this and this person did this. So you can often, for example, have an oral exam after you have this collaboration to see what the student's knowledge is. So you need to make sure people get the credit they should get, but you need to ensure that all students are learning. So the material properly. And this is something that I've done.
Yeah, I don't know how much you've, had students academically or work with students academically and then kind of on the research side at all. But you know, have you seen that kind of influence their work, you know, on the research side or anything like that, or had, I don't know, sorry, like how the technical training in good science has influenced their ability to do research and that kind of thing?
Fortunately, I've had great students. They've for some reason always known how to do the work ahead of time, which is great. But as I said, I tend not to choose the students that just get the highest mark. I tend to get the student that asks the most questions. So one of my students, as an example, one of my students in the past, she has her PhD. And, she didn't get the highest mark. She got a B or something like that in my course, in my graduate course on numerical methods. But she was an excellent PhD student, and she's an excellent scientist.
Allison, do you have a question?
Yeah, I was curious to, I guess, kind of going back, if you're done with that
No,
section.
go for it.
Okay, kind of going back, I was curious as to what you would define based on your experience and whatever else, how you would define multidisciplinary as well as interdisciplinary. I think that defining those in projects and research can be kind of difficult.
Well, lots of topics overlap. So there's mathematical physics, and sometimes that's in the physics department, and sometimes it's in the math department, right? So, for example, on the projects that I worked on, they can involve people in aerospace engineering and computer science, or mathematics. So that's multidisciplinary. And we cover different aspects of the problem. So I'm more fundamental, but those fundamental ideas need to be translated into computational techniques that are useful for applications, right? And that's where the more engineering focus comes. But we have overlapping knowledge bases. So that's multi. It could be considered. It depends on. So historically, sometimes the area of research I'm in has been in computer science department, and more interdisciplinary. Consider the algorithm development.
I guess I have a follow-up question for you is, as an educator, as well as in your experience and research and everything, do you think that having interdisciplinary teams is better than multiple different teams of different disciplines and kind of passing it off between each other?
So this is something else I would say is different about our education versus European education. You don't necessarily teach a set course. You might teach a portion of a course that's your expertise and pass it off to a colleague who has a different area of expertise. So I've seen the multidisciplinary approach to teaching work. I think it's very useful.
I think that working in teams, in that way of having, I guess, if we were to say that there's a team of 5 people that were all different disciplines, but working, together on a project versus having, 5 people in the math department and then 5 people in the comp sci department, and kind of doing your work and then passing it back and forth. I guess
It depends on the topic. It really depends on the topic. I would say just like with group projects on homework, you have to make sure everybody's pulling your weight, and that is the challenge with pulling that off. But I would say in terms of multidisciplinary versus everybody in one department, it depends on the topic.
So specifically about, Minds, how do you feel that Minds does with that, in terms of integrating multiple departments into, students' education, and then specifically integrating like the liberal arts and humanities kinds of topics into, our mostly all STEM focused degree programs?
I would say that Minds is working on integrating the humanities into our daily classroom.
Mhm.
And as far as this multidisciplinary nature in the classroom, I think that from what I've seen, our faculty are great about reaching out to other departments and saying, hey, here's the application of that, and working independently with people from other departments.
Mhm.
So I think Mike says an excellent job.
And I feel like we've talked a lot about kind of the values you have for the research world in terms of hiring students and also in the work you do. But I'm curious as to if you feel these have kind of evolved throughout your career, and if they started out different, changed as you gain more experience, or is that something kind of that's always been with you?
Well, I would say I've had excellent examples in graduate school.
Mm-hmm.
The people that I saw were excellent mathematicians, top notch, world class. But not only that, they were good people. And so they led by example. And so I'm going to tell you a story. So there's this one person that was a young assistant professor at the time, and now he's very famous. And he came up to me and he says, how does your advisor get you to work so hard? How does he get all his students to work so hard? What does he make you do to do? And I said, doesn't make us do anything. We want to. And it's because, he led by example. He had integrity, he respected us as researchers, and yeah, he was just an excellent example. So I've carried that with me.
Mm-hmm.
And he wasn't the only example I had in graduate school.
So you think that translates into kind of almost being on the other side of it now?
Yeah. And to him, his students mattered above all. I can still go to his office just on a whim, and he'll make 2 hours to speak to me. And he's a very busy person. So, yeah. And I think that he instilled in us that mentoring is very important, and just leading by example.
Mm-hmm. Yeah, I think that connects to the, ideas about not only, math and science being applicable to humanity on like the end goals and the applications, but also in the team development part of it and the people doing the science part of it.
Yeah. And the community building doesn't end when the project ends. It continues long after that.
Mm-hmm. Yeah, and then how, I feel like we talked, it seems like these values are very well integrated into your own work, but, how do you think they might be better integrated into the broader engineering and STEM education?
Well, I think establishing effective mentoring programs and recognizing that we come from different backgrounds and have different perspectives, providing resources to overcome any difficulty we might have, and just by ensuring people know these programs sometimes that's one way, because if you know something's there, then you start to think about it. But it's also in the way we teach our courses and assess knowledge, I think.
Very good.
Could I take that question one level more? Before we were talking about how robotics research and development of robotics has actually promulgated in bad ways gender and racial stereotypes that are inequitable and offensive. And you made a comment, if I understood you, with the mask, I have trouble sometimes, but that, well, a lot of that goes into the system. And so I wonder, from the point of view of the mathematics world, as a discipline, as a field, are there similar issues built into the system?
Oh, yes.
And so maybe could you elaborate what those are and to the extent what can be done about them? I know, at Minds we have the swim group, we've tried to do some proactive things, but at the end of the day,
Well, they did a study in the Netherlands a long time ago. So I was in the Netherlands, I was in the UK and Germany. And they did a study in the Netherlands saying that actually we need to reach out to people when they're in junior high. And this has worked. So this is one thing that I thought about. And in the UK, we, as professors, one of our jobs was to go to effectively high school and talk about mathematics and how to generate more interest in mathematics. So I think that outreach at a young age is incredibly important. And I think that in order to level the playing field, like I'm going to put another plug for my students on the Minds, Mathematics and Computing Collaborative. I think things like that are incredibly important. Because, yeah, if you never have access, how are you supposed to get the opportunity? So that's really important.
Yeah, I know a gentleman, Carl Reed, for a long time, who was the national director of NSBE, the National Society of Black Engineers. And he used a phrase about leaving talent on the table. And that's really what, certainly in the Western world, we've done with respect to women and underrepresented minorities. We've left a lot of talent on the table because the access is there.
Right, and going back to your example about robotics, I mean, we need to take the time to discuss the potential bad applications as well as good applications, and take the time to discuss a little bit about the history of why it's so unequal, and to recognize it.
Somebody had a question? Yeah or no?
Yeah, do you see just generally in the mathematics community a trend of kind of holding those same values of diversity and inclusion, or is the mathematics community going in the right direction, or is there a lot of pushback against that in general?
I think the math societies in general are really creating opportunities and really pushing for diversity. I think individually there are some people that are pushing back, but that's bound to happen with anything.
Great. Does anybody else have any final questions?
And maybe you answered this earlier, so apologies if you did. I was wondering, just like generally speaking, as a stereotypical like math, right? We all have to take up to DiffyQ. And we never really understand like the applications of these things, except for maybe in diffie, it's like, why do we need to know triple integrals? Like, how does this affect society really? Maybe it's an upper level, but is there talk in the math department of maybe like more so like even just changing problem statements, being like, okay, like this tank over here is doing this, and this is, you know, the rate at which it's going, and like it matters because it's supplying water to community. Have you guys ever like thought about maybe switching like problem statements to give it more of a context?
So first, I should say that I'm not in charge of the undergraduate.
Yeah.
But I'm sure that, so our motivation always is to help our students see the bigger picture. And I think that probably individual instructors do try and concentrate on how it can be applied. Because even, you know, I can't tell you how many times in my research I use integration by parts and the fundamental theorem of calculus, which you as a student probably think, come on, when am I going to see this? Right? But I call integration by parts the solution to all of life's problems. And it is, I'm serious. But you're right. Everybody needs to discuss more how it can be used. But you also have to acknowledge some people they understand something more in one context versus another.
Right.
Thank you.
Okay, I'm gonna try and word this well. It just came to my brain, it's a little complex. So, in terms of, at least in terms of STEM careers, and like once, you know, we get out of college and we go into the field, I feel like I've heard of a lot of engineers and probably even students being kind of hesitant about looking too far into like the more humanitarian or humanities aspects of problems, because someone told me one time when I asked about it that the problem itself without any of that is already complex enough, and then adding in, you know, how does politics influence that adds a whole other layer of it. Because I mean, I think all of that is like very valid, and those different layers of complexity. As an educator, how would you see, or can you see a good way of teaching students in STEM how to, you know, both be able to solve these complex, more technical types of problems, as well as be able to apply it to the complexities of society?
Right. So I think that comes in when we discuss the application and the time to discuss the various social aspects. You need to walk a fine line and make sure you're presenting an unbiased opinion and discussing the social aspects. But it is complex enough as it is, but I think more of the problem is that for so long, we're just have the mindset, just get the job done, right? Instead of taking the time to actually see the bigger picture. And I think presenting the bigger picture, and I think that goes along with assessment, right? So is an answer right or wrong? Yes or no? It's not the thought process. And actually in the Cambridge mathematics entrance exams, they don't necessarily expect that you get the answers correct. They just want to know your thought process. And I think that's quite valuable. It's reasoning out these issues. So I think if we change the way that we're doing our assessments, then that will help. That will go along towards that.
Okay, last one. Do you have any advice for somebody that kind of has not like just in STEM, I guess, in navigating those fields as both like a professional and like a person, as you mentioned earlier? By example. Any advice?
Well, make sure you maintain your core values. And it is, well, I wouldn't say, it wasn't difficult, but you see a lot of bad things out there. But you know what? You cannot control that other person. You only have control over what you do. And at the end of the day, you have to live with it. So that's what I would say is just to constantly remind yourself. There's this phrase that I love, not my circus, not my monkey. Right? You're not in charge of that other person. You're in charge of you.
Good advice. Thank you. All right, and thank you guys for coming, and thank you, Dr. Ryan, for
Thank you so much for
Being
the
here.
invitation.